You know that feeling, right? You've been hammering away at a pen test script. It finally works. But if someone asked you to explain exactly how, you couldn't do it with 100% confidence. Yeah, we've all been there. So today, we're going to talk about how to bridge that gap. We're going to turn those fragile, one-off lab scripts into a professional, truly defensible toolkit you can be proud of. And this is the exact moment I'm talking about. It's that brief, glorious flash of victory in the middle of the night, followed almost immediately by that cold, sinking feeling when you realize you have zero proof. You can't actually prove what just happened, and you probably can't even repeat it. It's a tough lesson for sure, but a really important one. So how do we fix this? Well, it's not just about writing better code or adding more comments. It's about a fundamental mindset shift. It's about totally rethinking what a toolkit is even for. We're moving away from this idea of just collecting more exploits and tricks, and we're moving towards building a reliable, trustworthy system. And this slide just nails the difference. On one side, you've got the common approach, which is basically treating your toolkit like a trophy cabinet of exploits. But on the other side, that's the professional mindset. Your toolkit isn't a collection of things. It's a workflow engine. It's a repeatable, reportable, and most importantly, scope-safe process. Okay, so what in the world is a workflow engine in our context? Well, think of it as a system that has a very specific job description. First, it validates your targets to make sure you're hitting the right thing. Then, it runs its checks in a predictable way, every single time. It gates any actions that could change something, and this is the big one. It writes evidence-ready artifacts. The whole point is so you can repeat a run and actually defend your findings. So let's boil this all down to 4 core jobs your toolkit has. Number 1, it runs checks. These are purely observation-only steps. Nothing gets changed. Number 2, it stays in scope, like obsessively. It has to validate targets. 3, it captures proof. And by proof, I mean minimal, verifiable evidence. And finally, number 4, you can repeat the run without having to spend hours relearning your own code. All right, so how do we actually start building this thing? Well, our first pillar is all about architecture. It's about building the skeleton before you even think about adding the muscles. Structure has to come before functionality. This right here is the trap we all fall into. You write this awesome little script that finds something cool, and it feels like a huge win. But then you write another one, and pretty soon you've just got this messy folder of scripts that can't talk to each other. They all have different outputs, different formats, and trying to create one coherent report from that mess, it's a total nightmare. The solution is actually pretty simple. It starts with a clean, durable folder layout like this. You have a core folder for all your config and validation logic. You have a checks folder for all your passive recon modules. Then you have an actions folder for anything that might actually change state on a target. And finally, a storage folder for your results and your data schemas. Seriously, this simple structure will save you weeks of refactoring later. And this is just so true. If you take one thing away from this section, let it be this. You need a universal translator that lets all your different scripts speak the same language. And that translator is a single, consistent results schema. It's the glue that turns that messy folder of scripts into a cohesive, powerful toolkit. Okay, so we've got our structure in place. Now let's talk about our second pillar, guardrails. This is all about building safety features into your toolkit from day one. We want guardrails before we even think about adding horsepower. Let's be clear, guardrails are not about someone wagging a finger at you. They are a professional design feature. Their one and only job is to prevent that single, catastrophic mistake, pointing your tool at something you don't own and are not authorized to test. Safety isn't a limitation. It's a feature that builds trust in your own tools. And the most important guardrail of them all? A dry run mode. Think of it like a seatbelt. It shows you exactly what your tool is about to do, what commands it would run, where the files would go, and then it just stops. It exits without doing anything. The very first time it catches a simple typo that saves you from a huge mistake, you will wonder how you ever lived without it. And look, you don't have to build a fortress overnight. You can add these safety features in tiers. Just start at tier 1 with a simple, hard-coded allow list. Then maybe add private range enforcement. Then make dry run the default. The point is, just pick a tier that feels right for you and start there. So that brings us to our third and final pillar, evidence. Every single action your toolkit takes needs to produce clear, trustworthy proof. It has to be evidence-ready by default, not as an afterthought. Man, this quote just hits so hard because it's so real. You find something amazing, but when you go to reproduce it for someone else, it's gone. Your incredible finding just turns into an unverifiable story. And that's exactly why things like run folders and correlation IDs are non-negotiable. They turn, "I think I saw something," into, "Here's the timestamp, here's the command, here's the proof." So the goal here is simple: log the truth. And that means a few things. You need separate logs. Debug logs are messy and they're for you. Evidence logs are clean and they're for the report. You need correlation IDs to trace every single action from start to finish. And you need good artifact hygiene. Hash your files, redact sensitive info, and minimize the data you're storing. And hey, if you need just one practical thing to implement today, make it this logline. Simply logging the moment your tool resolves a hostname to an IP address and explicitly confirming that IP is in scope can save you from so many catastrophic out-of-scope errors. It's such a simple, quiet, career-saving line of text. Okay, we've covered the mindset shift and the 3 pillars. Now let's stop talking and start doing. Let's put this all into practice with a super quick, actionable plan to get you started right now. Seriously, you can lay this entire foundation in about 15 minutes. First, just create a new repo with that core folder structure we talked about. Second, add a simple scope file with just one lab target in it. Third, implement a very basic dry run mode. Fourth, make your script create a time-stamped folder for each run. And finally, add just one simple recon wrapper that writes its output using your new schema. That's it. That's your professional starting point. And that really brings us to the final question you have to ask yourself. Is the toolkit you're building right now a liability generator, just a collection of dangerous shortcuts waiting to cause a problem? Or is it a repeatable, defensible system that truly showcases your skill as a professional? The choice is yours.